Hi everyone. Today I have picked up a problem from optics from IRODOV. The main purpose is just to clear a common misconception about the apparent depth, right? We frequently use the formula that real depth upon apparent depth is mu, but that is not true always. I mean, this is a special case when we are observing the depth at normal incidence, right? I mean, the normal viewing case, but this is not the generalized case. But here it is asked about a generalized case when we are observing at an angle theta with the normal to the surface. So if we can solve this, we'll later on put theta equals to 0 degree and we'll get our conventional result that real depth upon apparent depth is mu. So we'll prove that. But so let's start with the problem. I'm reading out it first. A man standing on the edge of a swimming pool looks at a stone lying on the bottom. The depth of the swimming pool is equal to h. At what distance from the surface of water is the image of the stone formed if the line of vision makes an angle theta with the normal to the surface? So here the case is, let's say this is the interface. Below this there is water and this is the normal. Sorry, this is the normal to the surface, and we are viewing the stone at an angle theta, right? So let's say this is the depth, so this length is h, let's say h is the depth, it is given only, and here's the stone that we are observing at an angle theta. So let's say this is one ray that is reaching our eye, and there is another ray something like this. So I'm drawing another normal at this point of incidence. So if we extend these two rays, so we'll get the image of the stone, and that will be the apparent depth. Right, so this is image, and this depth is h dash I am writing, and h dash is the apparent depth, and we need to find h dash only. And this angle is theta, as said in the question, that we are observing the stone at an angle theta, right? So second, I have assumed that it is incident at an angle theta plus d theta. So this is, you can assume that this is just the nearby ray of the first ray, and if this angle is r, then I can say that this angle is r plus dr. So this is the differential diagram also, you can say, because I have taken that the theta has increased by a small amount theta plus d theta, and r has also increased by a small amount r plus dr, just for sake of our calculation. And then let me mark this point as a and this point as b, just for convenience of our calculation. And then I am showing you two triangles. This is one triangle, sorry, this one is one triangle, and another one is this one. Right. So if I try to write this angle, what it will be? It will be d theta. Why? Because if this is the normal line, so this angle will be theta, right, as an alternate angle, sorry, as corresponding angle, and this whole angle will be theta plus d theta. So this small angle will be d theta only. So I'm writing this small angle only, that is d theta. And with the same logic, I can write this angle as dr, because this angle will be r, and this whole angle will be r plus dr. So that small angle will be dr only. Now from the green triangle, so let me once draw this little bit bigger size so that it can be understood easily. This is a, this is b, this angle is d theta, and this length was h dash, right? And this angle was theta, and this whole angle was theta plus d theta. Okay, so from this right angle triangle I can easily write this length as h dash sec theta, and then I am dropping a perpendicular from point A on this line. So as this angle is very small, d theta, we can assume almost this length and this length are equal. So this will also be h dash into sec theta, and this length will be h dash sec theta into d theta. I mean, like r d theta, you can assume this as a arc, right? A arc length of very small arc length whose radius is h dash sec theta. So you can write this length as h dash sec theta into d theta, like as we write s equals to r d theta. And our final target is to find AB, right? I am trying to find AB from green triangle and also from the blue triangle, and then trying to equate the two lengths. So this is h dash sec theta d theta, and this angle will be 90 degree minus theta, right? Yeah, so you must argue that angle B should be written as 90 degree minus theta plus d theta. I mean, if you consider this bigger right angle triangle, this angle is 90, this angle is theta plus d theta, so this should be 90 degree minus theta plus d theta, but it's nearly same, so we can write this as 90 degree minus theta only. Okay, so now you can relate that AB sine 90 degree minus theta will be h dash sec theta d theta. So sine 90 degree minus theta will be cos theta, so AB will be h dash sec square theta d theta. And now for the blue triangle I'm not going to solve, because let me show you, it is the same setup. I mean, this angle is dr and this length is h, this angle is r, and this is a, this is b. So as if from the green triangle to blue triangle we have substituted h dash with h and theta with r, and all the setup remains same. So I will directly write AB as h sec square r dr. So I am done with the length of AB from both the triangles. Now I am equating these two. So h dash sec square theta d theta is h sec square r dr. So h will be, h, I'm trying to find h dash, right? H dash is sec square r upon sec square theta, here dr upon d theta. So now I will bring the term dr upon d theta. So let me keep it here, and now I will use the Snell's law at this point of incidence. So for air medium I can, let me write as Snell's law. For air medium I can write the refractive index as 1, and angle of incidence is sine theta as shown in the figure, and for water I am assuming its refractive index as mu into sine of r as angle of refraction. So now I will differentiate both the sides so that I get the differential terms dr and d theta. So this will be cos theta d theta equals to mu times cos r dr. So from here on I can write dr upon d theta is cos theta upon mu cos r, right? So this is the dr upon d theta. I will substitute it here, and also I will substitute the r terms because I have assumed the angle r, but theta was given, so I will bring the answer in terms of theta only. That I can do from this first equation only, that sin r and sin theta are related, so from there I can relate sec r and sec theta. Sec theta I can keep it as intact, but I'll substitute sec r in terms of theta. So substituting these values, I'm writing h dash as h cos square theta into dr d theta. In place of dr d theta, I am writing cos theta upon mu cos r, and in denominator it will come cos square r. So cos square r, I can write it as root under 1 minus sine square r. So this will be 1 minus, in place of sine r I am writing sine square theta upon mu square from the first equation, this one. And yeah, here is also one cos r term, I need to substitute this one as well. So this one will be also root under 1 minus sine square, sorry, this will be whole square, because this is the value of cos r and we are writing cos square r. So this is the value of cos r, so denominator will be, let me write it in fair manner, h cos cube theta upon mu into 1 minus sine square theta upon mu square whole to the power 3 by 2, right? Because in denominator it will be finally cos cube r. So yeah, I think I am done with the solution, and this one is our final answer. We have bring in terms of h, mu and theta only. H and theta are given and mu is constant for a particular medium. So this is our answer. And as I was telling, that the most common formula that we used to use, that if this is the h real and this is the refractive index of the medium, and here let's say air is present, mu equals to 1, so we use that this is the apparent depth. And for normal viewing, when you are viewing in perpendicular direction to the interface, we write that apparent depth is real depth upon mu. So in this case we are viewing this at normal incidence, that means theta equals to 0 degree, angle of incidence is 0. So let's put theta equal to 0 here. If we put theta equals to 0 here, we will get h dash equals to h upon mu. So that is the formula we use a lot, but this is not a generalized formula, this is a modified one for normal viewing. So this one is a generalized that I have solved. So that's all for today, and thank you.